to produce SMT reflow and rework profile boards, and the procedure to produce SMT wave profile boards. Tools and supplies needed to perform these tasks include omega bond resin, omega bond catalyst, a Dixie cup and stirring stick for epoxy mixing, latex gloves for epoxy mixing if desired, toothpicks for epoxy spreading, a scale to weigh the resin and catalyst mixture, Kapton tape and cutting board, an X-Acto knife with blade, a drill and 15mm drill bit, SMT tweezers, K-type thermocouple wires, wire cutter, wire stripper, a small flat blade screwdriver, sub-mini TC connectors, a marking pen, a 10x magnification microscope, bake oven or hot air gun, heavy gloves for handling the baked motherboard, and a temperature measurement subsystem. For the SMT wave profile board procedure, a hot air soldering pencil and supply are required. Constructing a profile board can be performed on either a bare motherboard or on a fully populated one. Once the thermocouple attaching locations have been identified on a fully populated motherboard, prepare the board by removing the components and cleaning off the excess solder from the solder pads. Ensure that all excess solder is cleaned away at target thermocouple attachment locations. Prepare the omega bond epoxy by first placing some resin in a small Dixie cup. Note that the omega bond resin appears black in color, while the catalyst is white. Weigh the resin on a scale. Then add a small amount of catalyst. The ideal weight ratio is 10 parts resin to 1 part catalyst, or about 2.5 grams of resin to 1/4 gram of catalyst. Weigh the initial mixture and add small increments of catalyst if necessary until the proper weight ratio of 10:1 is achieved. Then use the stirring stick to thoroughly mix the two chemicals until the color is uniform. Once the resin and catalyst are thoroughly blended, set the mixture aside for later application. To ease motherboard preparation, identify and label the target thermocouple pads. Pad selection recommendations are available in the Intel SMT Profile Board MAS, as shown on this sample page. For each identified pad location, place a stick-on marker, in this case, a red arrow. Carefully carve a divot in the center of each pad with an X-Acto knife. With the divot as a starting point, drill a hole through the PCB with a 15mm drill bit. Do not exert force on the drill. Allow the drill bit to work its way through. After drilling, clean off debris and any burrs with oil-free compressed air. Then visually inspect all drilled holes with a 10x magnification microscope. Repair the Kapton tape by slicing it into thin strips on the cutting board. With the SMT tweezers, place a piece of Kapton tape over each of the drilled holes on the primary side of the motherboard. Remove the stick-on markers as you go. Now it's time to attach the thermocouple wires. Turn the board over and through the microscope, ensure that the tape is covering the holes on the top side. Using the microscope, insert a thermocouple tip through the back side of the board and tape the thermocouple wires in place. Flip the board over and ensure that the TC tips are touching the tape on the primary side, meaning they are flush. Flip the board over again and carefully undo the tie wraps if they haven't already been removed. Then loosen the wire coils. Organize and route all thermocouple wires towards the trailing edge of the board, securing them with Kapton tape in several places. This is what a typical routing looks like when completed. Flip the board over and with a microscope, verify that the thermocouple wire tips are flush with the motherboard pad near the Kapton tape. Adjust the thermocouple wires if needed before epoxy application. Flip the board over again and apply a small drop of the prepared epoxy over the thermocouple wires at drill hole locations and across bounded junctions. Using heavy gloves, place the board in an oven with the epoxy side facing up. Allow the epoxy to cure for 1 hour at 100 degrees Celsius. An alternate method for curing the epoxy is to use a hot air gun. Heat until the epoxy surface is dull. While the epoxy is curing, prepare the sub-mini TC connectors by unscrewing the two halves and separating them. After curing is complete, remove the board from the oven, being sure to wear heavy gloves. Inspect the quality of the curing process. The epoxy should be dull in finish and be uniform across its width. Here's an example of a well-cured epoxy strip. And here's a poorly cured one. Rework as necessary to correct any problems with the epoxy. Using a marking pen, number each of the thermocouple locations on the top side, with the number 1 TC being closest to the leading edge, meaning the edge that went into the oven first. Continue numbering all locations from the leading edge to the trailing edge, where the wires hang over the end of the board. Organize and cut the thermocouple wires into even lengths. Then strip the ends of the thermocouple wires. Insert the wire ends into the sub-mini thermocouple connectors, placing the red wire on the negative side and the yellow wire on the positive side. Tighten the screws and trim away any excess wire. Then replace the connector's cover. Label each connector to ensure it matches the thermocoupled location. Continue assembling and numbering the mini connectors until they've all been completed. To enhance thermocouple wire strength and durability for profile usage, twist or braid the wires, securing the end with Kapton tape. Remove the Kapton tape anchoring strips on the board with tweezers. A digital thermal meter is used for final labeling validation. Plug a connector into the thermometer. Monitor the temperature increase as heat is applied to the numbered corresponding thermocouple tip location. Individually check each connector in this manner. Finally, surface mount the component. The SMT reflow and rework profile board procedure is complete. Constructing a wave profile board involves similar steps and procedures as building an SMT reflow and rework profile board. In addition to board level preparation, the Intel SMT wave soldering profile board procedure involves thermocouple placement directly onto BGA components. For board level preparation, please refer to Module 1 in this video. Module 2 demonstrates only thermocouple preparation and attachment. The first step is to select the BGA component for thermocouple application. Mark the thermocouple ball location with a pen. Then remove the solder ball with a pair of SMT tweezers. Aided by a 10x microscope, clean away excess solder from the pad. Carefully carve a divot in the center of the pad with an X-Acto knife. Use the divot as a starting point and drill a 15mm hole through the PCB. Do not exert force on the drill. Allow the drill bit to work its way through. After drilling, clean off the burrs. Flip the BGA component into the live bug position with the BGA solder balls facing down. Viewing through the microscope, strip back the end of the thermocouple wire and insert it into the drilled hole. Secure the wire in place with Kapton tape. Flip the BGA component back into the dead bug position, meaning the solder balls are facing upwards. Adjust the thermocouple wire so that the wire tip is flush with the BGA pad. Flux the pad location and use a soldering system to create a solder ball covering the BGA pad and wire tip. Flip the BGA component back into the live bug position. After mixing the epoxy as demonstrated in Module 1, apply a drop of it over the wire and drilled hole. Wearing heavy gloves, place the BGA in an oven with the epoxy side facing up. Cure the epoxy for 1 hour at 100 degrees Celsius. An alternate method of curing the epoxy is to use a hot air gun. Cured epoxy should have a dull surface. After curing, the thermocoupled BGA component is ready for rework onto the SMT wave profile board. By following the procedures demonstrated in this video and supporting recommendations in the MAS presentation, you will be able to construct SMT reflow, rework, and profile boards that follow Intel's BKM. If you have any questions about what has been demonstrated in this video,